This last little piece of Chapter 5 kind of feels like it belongs in Chapter 6, but here it is in Chapter 5. Formula mass. So we've learned perhaps more than you care to know about chemical formulas. And now we're going to learn how to find out how much mass a particular compound has. So what's called the formula mass is the mass of a formula unit. So it's kind of like, if you had 5 people in an elevator, how would you figure out how much they weighed together if you didn't have a scale that you could put everybody on? You'd figure out, well, person number 1 weighs this much, and person number 2 weighs this much, and you'd find out how much each of them weighs, and then you'd add those together, right? That's what we do with a formula mass. You look at the formula, and you see, well, how many carbon atoms are there? How much does each carbon atom weigh? Okay, so that's the mass of carbon in there. And then, how much sulfur or chlorine or whatever else is in there. You find out how much each of those weighs, and then you add them together. So it's really not that complicated. So here, there we go. The formula mass. This kind of makes it look complicated, actually. The number of atoms of the first element, whatever that is, times the atomic mass of the first element. How do we find the atomic mass? We look on the periodic table. So like if it's carbon, we look up there, and that's that number underneath the symbol. For carbon, it's 12.011. And so you figure out how many atoms of those, you multiply them, and now you've got the mass of the first element. And then you add the number of atoms of the second element times its atomic mass, and then you just keep going throughout the formula. So let's do this example. Calculate the formula mass of dinitrogen monoxide, which is also called laughing gas. It has the formula N2O. So we look at the first element. It's nitrogen. How many nitrogen atoms are in this formula unit? 2, right? So we have 2 times the mass of nitrogen. So we look on the periodic table, 14.01 atomic mass units, because each atom weighs 14 atomic mass units. And then we have 1 oxygen, and each oxygen weighs 16.00 atomic mass units. So we put those together. I didn't think to get my calculator out. I was thinking nomenclature. I don't need a calculator for nomenclature. 2 times 14.01 plus 1 times 16. Calculator says 44. Let's do that a little better. 44.02 atomic mass units. So 1 molecule of N2O weighs 44.02 atomic mass units. Remember, an atomic mass unit is really, really small. It's like 10 to the minus 27 kilograms. So it's a very, very small mass unit. Any questions? Should we do another example? Let's do one more. Let's see. Let's do something with a polyatomic ion. Let's do PbNO3 2. Lead 2 nitrate. So you look at that first element, it's lead. There's 1 of them. Do you really need to multiply by 1? No, you don't have to. I'm just going to put it in here to be consistent. And lead is 207.2. Again, we're finding that on the periodic table. How many nitrogens are in this formula? 2. Because this is the parentheses there that's shrink wrapped. So we have 2 nitrogens, and each nitrogen weighs, we've already looked those up, 14.01. How many oxygens? 6. There's 3 in each of those bundle packs, and we have 2 packages. So there's a total of 6 of them, and I write number 2. 6 times 16.00. And then you get out your calculator. 207.2 plus 2 times 14.01 plus 6 times 16 equals, and this equals 331.22 atomic mass units. That makes sense? Maybe that makes more sense than the whole rest of the chapter does. Some of you may be curious, well, why, what about significant figures with these numbers? And why are you writing down 14.01 when the periodic table on the wall says 14.00674? Well, different periodic tables are going to give you different numbers of significant figures. And frequently in ones for students in beginning chemistry, they're going to round them off. And so like the periodic table on the inside cover of your book, they've rounded everything to 2 decimal places. Most everything. Lead is 207.2 because that's actually just as good as we know it. Not sure exactly why, but anyway, that's what it is. So what about significant figures on formula masses? Just go to 2 decimal places. That's going to be safe. The thing about the formula mass is that's usually not going to limit the significant figures in your answer. Usually it's some measurement that was made, a length or a mass or a volume or something that's going to be less precise than the formula mass. So we don't want to go crazy, but we don't want to, round things off too much either. So if you're using a periodic table like the one on the wall, and some of them have 5 decimal places, and you want to use all 5 decimal places, you go right ahead. It's fine. Okay. The master in chemistry, I'm not sure exactly what he wants. You'll have to find out what he wants. Okay. Sometimes they'll tell you, express your answer to 4 significant figures or something like that. And so then you just have to give him what he wants. So that's the end of chapter 5. So here are those review slides. I'm not going to read those to you. Chemical skills. But, students always ask me, are you going to give us a study guide? Right here, this is the study guide.